In this lesson, let's look at how to use the negative exponent rule. So think about this problem. 7 to the third divided by 7 to the fifth. Now we know from our quotient rule that 3 minus 5 would make negative 2. So one way to write this answer is to write 7 to the negative 2. But what does a negative exponent really mean? Well, to figure that out, we will write the same problem a different way. 7 to the third would be 7 times 7 times 7. And of course 7 to the fifth gives us 5 sevens all multiplied together in the denominator. Now we know that a 7 in the top will cancel a 7 in the bottom. So if we cancel all the 7s from the top, we're left with 1 over 7 to the second. So one way we thought about the problem, we got the answer 7 to the negative 2. And the other way, we got 1 over 7 to the positive 2. Well, these two things must represent the same amount. So, in fact, they do. 7 to the negative second equals 1 over 7 to the positive second. So you can see the relationship between the negative exponent in the top and the positive exponent in the bottom. This works for all bases and all exponents. If you have a negative exponent in the top, it's the same as having a positive exponent in the denominator. So, let's write each of the following expressions with a positive exponent, and then we'll simplify. So we'll get us several examples here to work on. And now let's write each one with a positive exponent, and then we'll reduce. So 9 to the negative second, if we write it as a positive exponent, will become 1 over 9 to the positive second. See, moving it to the denominator makes the exponent positive. And then 9 to the second is 81. So our final answer is 1 over 81. All right, let's do the same thing again. 4 to the negative third is 1 over 4 to the positive third. And then 4 to the positive third power is 64. So we get 1 over 64. Now notice both times we changed the sign of the exponent, but not the sign of the base. The base was positive and it stayed positive. Here the base is negative. So when I move this to the denominator and make it a positive 4 exponent, the base is still negative. It's only the exponent that changes sign, but the negative 2 base is still negative 2. Now, if we have to simplify this in the bottom, negative 2 to the 4th power would be 4 negative signs times 4 2s. So that would be a positive 16. Now, if we have no parentheses, remember we've encountered this before. If we don't have parentheses, this negative is not included in the base. We saw that back in chapter 1. So if we move the base to the denominator, the negative 1 will stay in the top, but the 2 to the 4th will be in the bottom. See, the negative is not part of the base, so it stays in the top. 2 to the negative 4th moves to the bottom where it becomes 2 to the positive 4th. Now, when we simplify, the negative 1 stays in the top, and in the bottom we'll have 2 to the 4th, which is 16. So the end result is negative 1 over 16. Now we have 5 to the negative 1, which if we move to the bottom to make a positive exponent, we'll have 1 over 5 to the positive 1, which is really just 1/5. And now I have some examples for you to try on your own. So I hope you'll pause the video and work them on your own and see how it goes. Alright, now we have 6 to the negative 2 becomes 1 over 6 to the positive 2, which is 1 over 36. And 5 to the negative third becomes 1 over 5 to the positive third, which is 1 over 125. Negative 3 to the negative 4th with parentheses means that the negative is part of the base, so we get 1 over negative 3 to the positive 4th. Now, 4 negative signs make a positive answer, and 3 to the 4th becomes 3 times 3 times 3 times 3, which is 81. So 1 over 81. On part D, the negative is not part of the base, so the negative 1 stays in the top, and in the bottom we get 3 to the 4th. So this time 3 to the 4th is positive 81, but I still have negative 1 in the top. And on part E, 8 to the negative 1 becomes 1 over 8 to the positive 1, which is simply 1 over 8. Now the same rule applies to a negative exponent that's in the denominator. If we want to make a negative exponent in the denominator positive, we just move it to the top. So now we have the rule working both ways. If you have a negative exponent in the denominator, you move it to the top. If you have a negative exponent in the top, you move it to the bottom. And moving it causes it to change sign. So now let's practice again, writing each expression with positive exponents, and then we'll simplify. Okay, this one has 4 to the negative third over 5 to the negative 2. To make the 4 to the negative third have a positive exponent, it will have to move to the bottom. And to make 5 to the negative 2 have a positive exponent, it will have to move to the top. And now we simplify each one. 5 to the second will be 25, and 4 to the third will be 64. On part B, we learned in the quotient rule, quotients to powers rule, that if we have an exponent applying to a fraction, then the top gets that exponent and so does the bottom. So now we only have to do what we did in part A. We'll move 4 to the negative second to the top and 3 to the negative second to the bottom so that the exponents are positive. And now 4 squared is 16 and 3 squared is 9. On part C, pay close attention. We have 1 over 4x to the negative 2. Now you have to ask yourself, what is the base of the negative 2 exponent? And I think you can see that without parentheses, the negative 2 is only working on the x. It does not apply to the 4. So the 4 does not have a negative exponent. So I will not move the 4. I will only move the x to the top, and this will become x squared over 4. Very simple, but very commonly missed. So give that one some thought and let that sink in. On part D, the x to the negative fifth in the top needs to go to the denominator, and y to the negative 1 in the bottom needs to go to the top. And instead of writing it as y to the positive 1, we simply just write y. Now I just want to underline a couple of things that we already talked about. In 1 over 4x to the negative 2, remember that the 4 does not have a negative exponent, so the only thing we moved was the x. And I just wanted to kind of make you think about that again. And on 3/4 to the negative 2, this is the way that we did it, but there's another way that's very helpful to think about fractions raised to negative exponents. You see that because they both had a negative exponent, the top and the bottom, we ended up moving both numbers. Well, instead of separating it out like that, what you can do is you can just think of it as, well, the negative causes the whole fraction to flip over. So 3/4 to the negative 2 makes 4/3 to the positive 2, and then you can say 4 squared is 16 and 3 squared is 9. And the way I always think of it is that the negative part of the exponent flips the fraction over. So we get 4 squared over 3 squared, which is 16 over 9. And usually instead of breaking it out this way, this is, in my mind, this is what I do, so that might be helpful to you as well. So let's try a few more examples that are kind of similar to the last set. And I hope that you'll pause the video and try these on your own before you look at the answers. Okay, so if we have 2 to the negative third over 7 to the negative second, we move both of those numbers to have positive exponents, and now we have 7 squared over 2 to the third, which is 49 over 8. On part B, 4/5 to the negative second is the same as 5/4 to the positive second, using what we learned on the last slide, and that's going to make 25 over 16. On part C, we know that y to the negative 2, where y is the only part that has a negative 2 exponent. The 7 does not have a negative exponent and needs to stay where it is. And on part D, both variables have negative exponents, and when we move them each, the x will have a positive exponent, which is a 1, which we really don't need to write.